first, here's a fact that we're all familiar with. Neural networks have taken over most AI tasks in today's world. They've become one of the major thrust areas in many pattern recognition and prediction and analysis problems. In many problems, they've actually established the state of the art, often exceeding previous benchmarks by very large margins. Here are some examples. Automatic speech recognition. For decades, we have been trying to develop automatic speech recognition systems that can perform as well as human beings and have failed miserably till very recently. Here's a headline from just a few years ago. Microsoft AI beats humans at speech recognition. And for the first time, on a standard benchmark task, they were able to outperform human beings using deep neural networks. Now, of course, most companies have automatic speech recognition systems that can outperform humans on several tasks. Here's another one, machine translation. If you had used Google Translate prior to November 2015, and if you had translated English to, say, Spanish, taken the translated Spanish and translated it back to English, what went in and what came out would not have looked similar at all. And then suddenly, in November 2015, Google Translate became a useful tool, and the translations actually began looking like something a human being might produce. And that's because they switched to using neural network-based translation. Here's yet another example. This is a picture I got from the web. I can't be sure of the authenticity of the picture, but here is a typical kind of result that you can now get for an image segmentation task using deep neural networks. In this picture, the system, the AI, has actually managed to segment out various objects and even label them. For example, it calls this a bicycle. It calls this a push cart. This sort of performance was unimaginable just a few years ago, but now deep neural networks make this possible. Here's another example. This is from a website called sitehound.com, and they have a video purporting to show a deep neural network based system tracking and labeling cars on the highway in real time. And here is a typical snapshot of the output. It's found and labeled a Nissan Sentra, a Honda Accord, a Honda CR-V. Now again, this is a phenomenal performance, and this wouldn't be possible without deep neural networks. Games. One of the standard tests for AI for very many years was whether a computer could beat human beings in games that were fundamentally intellectual in nature, like chess. We of course managed to build computer algorithms that could beat humans at chess a couple of decades ago, but Go was said to be the benchmark. It was assumed that a computer could never beat humans at Go, and then just a couple of years earlier we had the first AlphaGo system, which beat the world champion Lee Sedol. And these days you can actually download a program from the web where the game learns to play Go from scratch, and in a few short hours can beat a world champion, and that has been powered using deep neural networks. Here's an example of assigning captions to images. These are various, I don't believe you can actually read the captions, but if you look at the PPT you should be able to. And what you will find is that the computer has correctly captioned each of these images with amazing accuracy. And consider this, trying to describe an image such as this is actually a very complicated task even for a human being, but the computer is able to do this, and that is being done by a deep neural network. And so on, in a variety of problems, from art to astronomy to healthcare and even predicting stock markets. Deep neural networks are setting the state of the art and producing amazing results, and these things are only getting better with time. And of course there's the business with the employment market. With all of the success of deep neural networks these days, if you're not familiar with deep neural networks and you are not an expert in the technology in some sense, it actually becomes hard to get a job in the tech world. And so the objectives of this course are to try to impart some knowledge about this amazing new phenomenon to you guys. We want you to understand neural networks. We want you to be able to comprehend the models that do all of the previously mentioned tasks and maybe even build these models. We want you to be familiar with terminology. For example, here is a very nice blog, www.datascientcentral.com/profile/blogs/concise visual summary of deep learning architectures. This blog actually maintains a list of all of the latest neural network architectures that are being employed, and it's our hope that when you're done with this course, you will be able to comprehend all of these architectures. Our objective also is to finally enable you to be able to fearlessly design, build, and train networks for a variety of tasks. We're not claiming that you're going to become an expert in deep neural networks in this one course, but although you may not be an expert, you'll actually be fairly handy, and it will set you up for further work. At a broad level, here is what we will be trying to teach you. We will cover concepts, starting with some historical perspective, talk about different types of neural networks and underlying ideas, how neural networks can be learned, including training and practical issues, and about various kinds of architectures and applications. The course is going to try to balance implementation and theory, with the focus being on trying to impart concepts to you. We are not so highly focused on the theoretical aspects, the mathematics, the squiggles. We want you to understand the subject. And there's also a heavy focus on practical implementation. We hope that when you're done with the course, you'll be familiar with training, you will be able to implement various neural network architectures, implement state-of-art solutions for some problems, and overall, you must be set up for further research or work in your research area using deep neural networks. The topics we will cover are these. We're going to go through basic network formalisms, including multi-layer perceptrons, convolutional networks, recurrent networks, Boltzmann machines. We will look at some advanced formalisms like generative models such as variational autoencoders and adversarial models like GANs. We will touch upon several practical topics like computer vision, how you recognize images, text processing, modeling and generating language, machine translation, that is sequence-to-sequence modeling, modeling distributions and generating data, reinforcement learning in games, and speech recognition. There is a list of books on the course webpage.